All right, folks, I'm back. I fixed my worksheet here. That was bizarre, but we're back in business. So, again, this is the tree diagram for figuring out how many ways the Vikings, Bears, Lions, and Packers can finish. So, before I get into the tree, let me just remind you that here we've got the counting principle, right? Which simply means to list out the number of um, options for each step. Okay, so in this case, you have four steps. First, you can pick who's first, and then you can pick who's second, pick who's third, and pick who's fourth. Okay, um, you can pick. So for your first place team, how many options do you have? Well, you have four because there's four teams. And then second place, you only have three options left, right? Some, for example, on the tree here, if you pick the Vikings to win it, well, they're done. They won it, so now you only have three teams left for second place. And then, say you had the Vikings and the Packers, now you only have these two teams for third place. By the time you get to last place, there's only one team left to put there. And then the counting principle says you just multiply these through. So there are 24 different ways the standings can play out at the end of the year. Okay? This is called factorial. Exclamation mark means factorial. Um, n factorial then with notation would be you take n times n minus 1 times n minus 2 times dot, 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 dot. You keep counting down until you get to 1. So let me just show you the tree diagram quickly because that visual helps you as well. On the first part, I have 1, 2, 3, 4 branches because you can pick, right? You can pick any team to be first. You could go this route and say the Bears are going to be first. You could go the Packers. Nah, not the Packers. The Lions are going to find a way to lose, but you could pick them. All right. So let's say you are, let's just zoom in on the front, the Vikings here. The Vikings win. Yay. If they won, now you only have three branches for second place: Packers, Bears, Lions, right? Let's go this route. Vikings, Lions, okay. Now I only have two branches because the Vikings and the Lions have already been placed. Now I've got just Packers and Bears remaining. So two. Then if I did Vikings, Lions, Packers, the last team is kind of pigeonholed. They have to go there because they're the only team left. There's only one option for that spot. So you can see the 4 times 3 times 2 times 1 in the tree. You can use factorial for all kinds of questions. Like if I said on the track tomorrow, not tomorrow, in the spring on track and field days, how many ways can the racers finish a race? And on the track, there are 8 lanes, so you would just do 8 factorial, which actually is a much bigger number than you might think. It means 8 times 7 times 6, 4, 3, 2, 1. This is counting all the different ways 8 runners can finish like a 100-meter dash. On the calculator, if you hit your number first, and then you go to math, go over to probability, and it's number 4 right there, the exclamation mark. And look at that, 40,000 ways, 40,320 ways. You gotta be kidding me that the race could finish in random order, okay, if you mix them up. Crazy, crazy. All right. Next, number 5. If I made up a make-believe Powerball, to win Mr. Feig's AP Stats Powerball, a person must choose 3 distinct numbers between 0 and 9 in the correct order. How many different 3-digit Powerball numbers can be created? All right, so what I've done here, maybe I'll just play it out for you. I know you see it, but walk through it. You really only have 3 decisions to make. Sometimes, if you didn't know this, when you buy a Powerball ticket or a lottery ticket, you can actually pick your own numbers. You can say, I want the first number to be a 4, and then I want the next one to be a 6, and then a 1, okay? But in these blanks, I'm not going to put the number I pick. I'm going to put the number of options I have for each one, right? So my first number can be anything 0 through 9. And remember, 0 through 9 is 10 digits. It's not 9. So you can pick any of the 10 numbers, right? Now, it says distinct, so that simply means no repeats. I can't make my number like 777. I can't do that. So in other words, once I've picked a number, it's gone, and now I have to count down. Now there's only 9 options, and now 2 numbers are gone, and now there's only 8 options. I have to count down. When you multiply those, right, well, 7 times 8 is 72, times 10 is 720. So the order definitely matters here, right? It says in the correct order. When order matters, this is called a permutation. A permutation is the number of ways to order R items chosen from n total items. Okay? The notation is here, and you can do this on the calculator as well. NPR is, so this is the total number of items, and this is the number of items chosen. So NPR is equal to n factorial over n minus r factorial. Okay, your calculator has this button. Let me show you. It's right where the factorial one was, if you caught on. So I'm trying to do 10p3. So type your 10 first, go to math, go to probability, go to number 2, and type in 2. Type in 3, 10p3. And there it is. Okay. What it's doing when you type in 10p3 is it's this formula. I think it's valuable to do it by hand once or twice. So the 10 is the n, so the numerator is 10 factorial. The bottom is 10 minus 3 factorial. So I think you'll see a pretty cool connection here. So 10 factorial is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And the denominator, well, wouldn't this be 7 factorial, right? Which is 7. Just gonna scooch it over for reasons you'll see. 7, 6, 5, 4, 3, 2, 1. So voila. All of these cancel all of these. And hey, look at that, folks. That's what we did. 1098. That's what we did when we were using the counting principle. So it does work. The calculator button is nice and quick once you are confident that it is indeed 10p3. Number 6. This is an extension for tomorrow's lesson. So if you don't grasp this, or you want to, I guess, just go do the homework and now come back to this later, you sure could. Number 6. There are 10 kids in the class, 10 students. Each student is going to shake hands with every other student in the class. How many handshakes occurred? Okay. Okay. The thought I have is, in purple here, is that I'm just, if you can see it, it's 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. You're not going to count a handshake twice. So there's 10 kids, right? The first kid, we could line all 10 kids up in front of the room, right? And the first kid could go down the line and shake everybody's hand. That student would shake 9 hands, right? And then once they've done that, the first student is done. right? They have shaken everybody's hand, so they're done. Then the second person in line says, okay, I'm going to shake everyone's hand that's still in line. There's only 8 people in line, right? Because the first person's done. So the second person only needs to shake 8 new people's hands. And you can see then how this is going to continue. The third person then does not have to shake the first person's hand or the second person's hand because they already did. And they don't shake their own hand. So, 7, 6, 5, 4, 3. They shake 7 hands. And then the fourth person shakes 6 hands. The fifth person shakes 5 hands and all the way down. You can add that up and you get 55 handshakes. Okay? Maybe you're like, nah, that's just too abstract. You can make a tree diagram. Okay? Now, this tree diagram is massive, so I have not drawn the whole thing. So, when I draw the tree diagram, what I'm essentially doing is I'm asking myself, how many groups, let me say pairs, how many pairs of students are there? Right? So you can see my tree diagram, I pick one person, then I pick 2 people. Once I've picked a pair of students, what do? They shake hands. So I'm really just picking a pair. I'm picking a small group. So first I have to pick my first student, and my arrow here signifies this will go all the way down to student number 10. I'm just running out of room, okay? So let me zoom in here. If I picked person number 1, I numbered all the kids off and said, person number 1, you are going to be paired up with someone else. Person number 2, then, I only have 9 options because I can't pair up 1 with 1, right? I have 2, 3, 4, 5, 6, 7, 8, 9, 10 remaining to pick from. So what if I did this? If person 2 was my first person selected, well, then they could be paired up with 1. And then notice they could be paired up with 3. I skipped 2 because 2 can't be paired up with 2. So 1, skip 2, 3, 4, 5, 6, 7, 8, 9. This again is 9 branches, right? This is 9 branches. So how many total branches would be in this tree, right? I have 10 branches here and 9 here. So there are multiplication. There are 90 branches in this tree diagram. There are 90 outcomes or 90 pairs in this tree diagram, okay? Now, here's the kicker. But each pair, each handshake is listed 2 times because order does not matter, okay? I've tried to mark out a few repeats here. So let me zoom back in. Right here, I've got 1 and 2. So it was 1, 2, purple. Here I've got person 2 and then person 1, 2, 1. In practice, isn't this the same handshake as this? It's the same 2 kids shaking hands, okay? So it's been listed twice. Again, it happened here. Here's 1, 3, and then here's 3, 1. It happened again. If you notice and think about it here, every outcome is going to be double counted. Here's 2, 3, and here's 3, 2, the green ones. So the tree does have 90 branches, but there's a lot of duplicates. Everything is repeated. So I have to take my 90 and I have to divide by 2 because it will divide out my repeats. There are only 45 unique handshakes. 45. I guess I added up incorrectly here, didn't I? Womp womp. Sorry about that. You're probably like, I tried it on my calculator. It didn't work. 10 times. Yes, sorry about that. Sorry, 45 handshakes. 45 different pairs of kids that would be shaking hands. So, we'll really dig into this more tomorrow. But why are we dividing by 2? It's because this is a combination, not a permutation, and order does not matter in a combination, okay? We use combinations when we are selecting a group of people. And that's what you're doing here. You're saying how many groups of 2 are in this class of 10 students. The notation is a C instead of a P, right? C for combination. And the formula is you take what you would have with NPR and you divide by R factorial. And dividing by R factorial divides out the repeats. N and R are the same as they were earlier in the lesson. N is the total number of items, and R is the number of items chosen. Okay, so in this case, what you would have with the notation is there's 10 kids in the class. That's the total number of kids. And I'm only selecting 2 kids. I'm only picking groups of size 2. So the numerator would just be 10p2. That would be putting 2 kids in order. That's 90. That would be the 10 times 9, if you want to think of it that way, right? But then I'm dividing by 2, factorial, because I'm dividing out the repeat results, which is why I have 45. All these buttons are right next to each other in the calculator. So 10, math, probability, there. It's option 2, 3, and 4, NCR 2. So you could quickly answer, if you're catching on, I could say, well, in this class, how many groups of 3 could I make? Well, 10, C, 3. 120 groups that are size 3. All right, thanks for listening. Have a wonderful day. Thanks for your hard work.